Look up. On any given night, if the clouds permit, it is there, a silent silver companion on our journey through the void. The moon. It is the most familiar object in our night sky, a constant presence that has shaped our calendars, our tides, our myths, and perhaps even our dreams. For all of human history, we have gazed upon its surface. We have seen the same serene face looking back at us, the same dark plains, the ancient Maria etching a face, a rabbit, a figure we instinctively recognize. It is our cosmic anchor, a portrait of permanence in a universe defined by ceaseless chaotic change. From the first moment a human eye looked toward the heavens, one truth seemed self-evident, as obvious as the ground beneath our feet. The moon does not spin. It hangs there in the black velvet of space, a steadfast lamp, its features locked in place, unmoving, unchanging. This perception is woven into the very fabric of our culture. Poets have written of its constant gaze. Lovers have sworn oaths under its unwavering watch. Ancient astronomers charting its progress across the constellations mapped a surface that never offered a different profile. It was a foundational assumption, a piece of celestial furniture so reliable that to question it would have seemed like madness. It simply is, the same yesterday, today, and tomorrow. But what if this fundamental truth, this shared experience of millennia, is not a truth at all? What if it is a deception, a grand cosmic sleight of hand performed on a celestial stage for an audience of an entire world? What if the most unmoving thing we know is in fact in perpetual motion? The story we are about to tell is a strange one. It begins with that simple, comfortable illusion and descends into a reality of immense gravitational forces, of planetary collisions, and of a slow, inexorable dance that has lasted for billions of years. The astonishing truth is this: the moon spins. It is spinning right now as you watch this. It completes a full rotation on its axis, a complete turn methodically, relentlessly, without ever pausing. The sensation of vertigo you might feel at this revelation is justified. It challenges a lifetime of observation, a collective human certainty. How can it be turning if we never ever see its other side? This is the heart of the mystery, the central clue in a detective story written across the expanse of our solar system. The solution is not a simple contradiction, but a subtle and profound piece of cosmic choreography. The moon turns on its axis in almost the exact same amount of time it takes to complete one full orbit around our planet. Its day is the same length as its year. Imagine two dancers in the center of a grand ballroom. The Earth is one dancer standing relatively still. The moon is its partner circling around it. But as the moon circles, it also turns, pirouetting slowly, so that it always keeps its face pointed towards its partner. One step in its journey around the Earth corresponds precisely to one small degree of its own private turn. The two motions are perfectly, impossibly synchronized. A single celestial lap requires a single solitary rotation. The performance is so flawless that from our vantage point, the spin becomes invisible. We are locked in a perpetual stare. This phenomenon is not a quirk. It is not a coincidence. It is called synchronous rotation, or more evocatively, tidal locking. And it is the final dramatic outcome of a gravitational war that our planet waged against its only natural satellite. This isn't just a story about orbital mechanics. It is a story about how gravity is not merely a force that pulls. It is a force that stretches, that kneads, that deforms. It is a story of how the immense gravity of Earth reached out across 250,000 miles of empty space and seized hold of the moon. It is a tale of how our world, through a patient and relentless campaign of gravitational friction, bled the moon of its original chaotic spin. Imagine a time billions of years ago in the solar system's wild youth. The moon was a newborn, a molten sphere of rock coalesced from the debris of a cataclysmic collision with the young Earth. It was likely spinning much faster then, a frenetic, untamed rotation, a gyration independent of its orbit. Had we been there to see it, we would have witnessed all of its faces. The familiar near side would have swept past, followed by the alien crater-pocked landscapes of the far side, a hemisphere that today remains eternally hidden from our direct view. But the Earth would not permit this independence. Our planet's gravity is not a uniform field. It pulls more strongly on the side of the Moon closer to us than it does on the side farther away. This difference, this gravitational gradient, created a bulge, not just in the Moon's oceans, which it didn't have, but in the very rock of its body. The Moon was stretched ever so slightly into an oblong shape, a cosmic football with its ends pointing toward and away from Earth. As the primeval Moon spun faster than it orbited, this tidal bulge was dragged slightly ahead of the direct line between the two bodies' centers. Earth's gravity then tugged back on that leading bulge. It was a constant, nagging, relentless pull, a celestial brake applied without mercy for eons. This gravitational friction generated immense heat inside the Moon, dissipating its rotational energy, slowing it down. Millimeter by millimeter, second by second, century by century, the Moon's spin was stolen. The process was agonizingly slow, a sleepy geological process unfolding over a timescale that dwarfs human comprehension. It was a silent, invisible contest of wills fought by titans, a gravitational arm wrestle across the void, and the Earth won. Eventually, after perhaps hundreds of millions of years of this breaking, the Moon's rotation slowed to a critical point. It slowed until its spin precisely matched the speed of its orbit. At that moment, the tug-of-war ended in a stalemate. The tidal bulge aligned perfectly with Earth, and the breaking stopped. The Moon settled into its new permanent equilibrium, locked, captured in a gravitational gaze from which it can never escape. It had lost the freedom to show us its other face. This is why the Moon appears not to spin. Its motion is an artifact, a scar, a beautiful and chilling monument to the overwhelming power of our own planet. We see a static, peaceful orb, but we are actually looking at the conclusion of an ancient and violent gravitational struggle. The unchanging face of the Moon is a flag of surrender. This documentary is the story of how we uncovered this strange truth. It is not a tale of a single brilliant discovery, a lone genius shouting eureka from his observatory. Instead, it is a collection of what we like to call sleepy scientist stories. It is a narrative woven from centuries of quiet patience, of meticulous observation night after night, of subtle calculations filling chalkboards and notebooks. It is a story of how our understanding grew layer by layer as one generation of thinkers built upon the work of the last. It began with the simple act of watching, of noticing the constancy. Early philosophers like Aristotle noted the same face was always visible, but their explanations were rooted in a geocentric, perfect cosmos where celestial bodies were flawless spheres moving in divine ways. The Moon showed one face because that was its ordained nature. The revolution began when we started to understand motion itself, with thinkers like Kepler, who revealed that orbits were not perfect circles, and Newton, who gave us the universal law of gravitation. Suddenly, the cosmos was not a place of divine mystery, but a magnificent machine governed by laws we could comprehend. And within this new clockwork universe, the Moon's behavior was no longer a given. It was a problem to be solved. Why was this one gear in the grand machine seemingly frozen? The clues were subtle, almost imperceptible. Astronomers noticed that we could over time see slightly more than 50% of the Moon's surface. A tiny sliver around the edges would periodically become visible. This phenomenon, called libration, was the first crack in the illusion. The Moon appeared to wobble, to rock back and forth ever so slightly. It was a tantalizing hint that its motion was far more complex than a simple static presentation. These librations were the footprints of a hidden dance. They arose because the Moon's orbit is not a perfect circle. and its speed varies while its spin remains almost perfectly constant. This mismatch between a steady rotation and a varying orbital speed allows us to peak just for a moment around its eastern and western limbs. Unraveling this wobble was a mathematical epic. It required centuries of precise measurement and theoretical work, from the days of Cassini and Newton to Laplace and Lagrange. Each discovery was a quiet triumph, often hidden away in dense academic papers, the result of a lifetime spent staring at numbers at the moon, at the stars. These are the sleepy scientist stories, the stories of quiet dedication, of the slow, methodical accumulation of knowledge that allows us to piece together a puzzle on a cosmic scale. It's the story of how we moved from asking, "Does the moon spin?" to understanding the profound physics of tidal forces that govern not just our moon but countless worlds across the galaxy. Tidal locking, we now know, is not an anomaly. It is the ultimate fate of most moons that orbit close to their parent planets. The moons of Mars are tidally locked. The great Galilean moons of Jupiter are locked. The giant moon Titan orbiting Saturn is locked. Even distant Pluto and its moon, Charon, are locked to each other, a binary system where both bodies perpetually face one another, like partners frozen in the middle of a waltz in the dark. Our moon is not a special case. It is a profound example of a universal principle at work. And the story doesn't even end there. The same tidal forces that locked the moon's spin are still at work today. Just as the moon's body is stretched by Earth's gravity, the Earth's oceans are stretched by the moon's gravity. The tides that rise and fall are our planet's own tidal bulge. As the Earth spins much faster than the moon orbits, this oceanic bulge is dragged ahead of the moon in its path. Now the moon's gravity pulls back on our planet's tides. This interaction acts as a brake on the Earth's rotation. Incredibly, the moon is slowing us down. Our days are getting longer by a tiny fraction of a second each century. It's an imperceptible change on a human timescale, but over geological eons, it is profound. The Earth's rotation is winding down, a victim of the same gravitational dance that it once used to subdue its companion. And there is a final reciprocal twist in this tale. As the Earth's spin slows, that lost rotational energy has to go somewhere. It is transferred to the moon's orbit. The moon is using that energy to push itself away from us. Every year, our silent partner recedes by about 1.5 inches. It is a slow, silent, and inevitable escape. The bond is loosening. The cosmic stare is being broken one infinitesimal step at a time. So the serene, static image of the moon is a mask. Behind it lies a dynamic, evolving system, a story of a shared and violent past, a codependent present, and a future of slow separation. The question, "Why doesn't the moon spin?" is the key that unlocks one of the most elegant and far-reaching stories in all of science. It's a question that takes us from a simple glance at the night sky to the very heart of how gravity shapes the universe. It forces us to confront the difference between what we see and what is truly happening. It reminds us that the cosmos is rarely as simple as it appears, and it is a testament to the power of quiet, persistent inquiry. The power of those sleepy scientists who over generations looked past the obvious and dared to question the constant. They are the ones who taught us to see not a static portrait in the sky, but a dynamic, spinning, wrestling, and receding world. Join us as we unravel the clues they left behind. Let us piece together the story of the moon's hidden motion, and in doing so discover the strange and beautiful truth about our place in this gravitational dance. The most familiar object in our sky is about to become a stranger, and its story is more dramatic than you could ever imagine. Look up tonight. If the clouds have parted, you will see it. A familiar face etched in shades of silver and ash. It is the most constant companion humanity has ever known, a silent witness to our entire history. From the first moment our ancestors gazed at the heavens, that same stoic visage has looked back. The same dark seas of ancient hardened lava, the same bright highlands scarred by relentless impacts. You have never seen its other side. No one on Earth, for all of human existence, ever has. This steadfast gaze has woven itself into our myths, our calendars, our very sense of time and tide. But this constancy, this seeming stillness, is a profound illusion. It hides a secret about motion and time, a story of a violent past, and a truth about the universe that is far stranger than a simple, unmoving stone in the sky. The question isn't why the moon looks so still. The real question is why it performs a perfect hidden dance, a cosmic pirouette so exquisitely timed that it took us millennia to even recognize it was happening. To understand this celestial sleight of hand, we must first travel back, not through space, but through time. We must stand with the first sky watchers who knew nothing of gravity or orbits, but who knew the moon more intimately than we do today. Imagine a world without electric light, a world where the darkness of night was absolute profound. Here the sky was not a distant curiosity. It was a living, breathing part of existence. And ruling this nocturnal kingdom was the moon. It was a lantern, a guide, a clock, and a god. For countless generations, people gathered around flickering fires, telling stories about the patterns they saw on its surface. A man carrying a bundle of sticks, a rabbit pounding herbs, a woman weaving at a celestial loom. Every culture on Earth, from the Maya to the Maori, from the Norse to the San people of the Kalahari, developed its own mythology for the lunar features. They saw different figures, told different tales, yet crucially they were all describing the very same canvas, the same arrangement of light and shadow. This was a fundamental shared truth of the human experience. The moon did not tumble or turn to show a different profile. Its face was as unchanging as the mountains on the horizon. This wasn't a puzzle to them. It was a simple fact of the world. It was a source of stability in a universe of cycles. The sun rose and set. The stars wheeled across the firmament. The seasons turned with inexorable rhythm. And the moon, while it waxed and waned, growing from a sliver to a brilliant disk and back again, never once averted its gaze. This reliability was woven into the fabric of early civilization. Its predictable phases became humanity's first calendar, allowing farmers to know when to plant and when to harvest. Its steady path across the zodiac gave travelers their bearings. It was the metronome of the ancient world. But as observation became more systematic, as simple watching evolved into the science of astronomy, this constant face began to shift from a comforting certainty into a subtle, nagging question. In the flourishing cities of Mesopotamia, priest astronomers climbed their ziggurats using clay tablets to record the moon's every move. They tracked its path against the backdrop of the stars. They predicted its phases with astonishing accuracy. They even learned to foretell the terrifying spectacle of an eclipse when the Earth's shadow would consume the lunar disk. In ancient Greece, thinkers were moving beyond myth. They sought to understand the cosmos not as the whim of gods, but as an ordered, knowable system, a cosmos. They measured the Earth's circumference. They debated whether our world or the sun lay at the center. They modeled the intricate dance of the planets. Through all this brilliant intellectual ferment, through centuries of meticulous naked-eye observation, the moon's persistent loyalty remained a constant data point, a given, an axiom of the night sky. It traveled, it changed in brightness, it moved through phases, but it did not spin, or so it seemed. This single observable fact was so obvious, so monolithic, that for thousands of years almost no one thought to question it. It was the quietest clue in the cosmos, hiding in plain sight, waiting for a new way of thinking. It was waiting for us to understand the difference between a journey and a turn. To unravel this mystery, we must first arm ourselves with the same concepts that finally unlocked it. We need to learn the fundamental grammar of celestial motion. The distinction between two simple words that describe everything from a child's spinning top to the majestic sweep of a galaxy: rotation and revolution. These two ideas are the heart of all movement in the universe. They seem simple, but their interplay creates all the complexity we see in the heavens, from the length of our day to the changing of our seasons. Let's begin with rotation. Imagine a figure skater pulling in her arms, transforming into a dizzying, beautiful blur. She is spinning on an invisible line running through her center from her head to the ice. This line is her axis of rotation. Rotation is this internal motion, a body turning on itself. Our own planet, the Earth, is a grand example. It spins on an axis that runs from the North Pole to the South. This rotation is relentless, and it governs our lives. It is the reason we have day and night. As your spot on the globe spins into the light of the sun, your day begins. As it turns away into its own shadow, night falls. One full rotation takes approximately 24 hours. It is the most fundamental rhythm of life on Earth. Now, consider the second kind of motion revolution. Think of a satellite whipping around the Earth. It isn't spinning on its own axis. It is traveling along a path, an orbit around another object. Revolution is an external motion. It is the journey one body makes around another. Our Earth does this too. While it is constantly rotating, creating our days, it is also simultaneously hurtling through space, following a vast elliptical path around the Sunday. This journey, this revolution, takes about 365 days. We call it a year. This revolution, combined with the tilt of Earth's rotational axis, is what gives us our seasons. So every object in the sky is doing one or the other, or both. A planet can rotate quickly but revolve slowly. Another can revolve rapidly but barely rotate at all. Venus, for instance, has a day that is longer than its year. It rotates so glacially that one turn on its axis takes more time than its entire journey around the Sunday. Jupiter, a colossal giant, rotates with breathtaking speed, completing a day in under 10 hours, even as it takes 12 long years to revolve around the Sunday. Every planet, every moon, every star has its own unique blend of these two fundamental movements. It is the signature of its history, its formation, its destiny. So armed with this simple but powerful distinction, let us return to that familiar face in our night sky. Let us return to the moon. We see it circling us month after month. That is its revolution. It is clearly making a journey around us. The ancient astronomers tracked this orbit with precision. It takes the moon about 27 days to complete one full revolution around the Earth. But what about its rotation? What about its spin? The evidence of our eyes for thousands of years has screamed the same answer: nothing. It shows us the same face, so it must not be rotating. It feels intuitive. It feels obvious. If an object isn't turning, you'll always see the same side. And this seemingly logical conclusion is precisely where the beautiful, subtle, magnificent error lies. It is the key that unlocks the first door of our mystery. Let's conduct a thought experiment right here on Earth. Imagine you are in a large open space. In the center stands a magnificent statue. Your goal is to walk around this statue, keeping your eyes fixed upon its face the entire time. You start at a point looking directly at the statue. Now begin walking in a circle around it. To keep the statue's face in your view, what must you do? As you move to the side, you have to turn your head. As you continue your journey to what was originally your back, you have to pivot your entire body. By the time you have completed half of your circle, you are facing the opposite direction from where you started. When you complete the full circle and return to your starting point, you have also completed one full 360-degree turn. You had to. There was no other way to keep the statue in sight. You performed one rotation for every one revolution. Now let's try it again. This time, walk around the statue without rotating at all. Keep your body pointing in the exact same direction, let's say facing north, for your entire journey. You start out looking at the statue's face, but as you begin to circle it, you'll soon be seeing its side. Halfway through your orbit, you will be looking at its back. As you complete the journey, you will have seen every side of the statue in turn. This is what it would look like if an object revolved around us without rotating. We would see every part of its surface. The Earth's moon does not do this. We never see its back. We only ever see its face. This leads to a stunning, counterintuitive conclusion. The moon is not still. The constant face it shows us is not evidence of a lack of spin. On the contrary, it is the undeniable proof that the moon is spinning. It is performing the exact same celestial ballet you did when you kept your eyes locked on that statue. It rotates on its axis precisely once for every single time it revolves around the Earth. One turn for every one journey. Its day is the same length as its month. This is a state of perfect, exquisite synchronization, a condition astronomers call synchronous rotation. Think about what this means. For every kilometer the moon travels along its orbit, it turns just a tiny, imperceptible amount on its axis. Not too fast, not too slow. The two motions are linked by an invisible perfect gear ratio. If the moon rotated just a fraction faster, we would slowly over the centuries see a sliver of its far side peeking around one edge. If it rotated just a hair slower, the other side would eventually reveal a hint of its secrets. But it does neither. The lock is perfect, so the mystery we set out to solve has just transformed. The question, why doesn't the moon spin, was the wrong question. It was based on a flawed though understandable assumption. The real question, the far deeper and more fascinating puzzle, is this. Why does the moon spin in this extraordinary perfect way? How did its rotation become so precisely tethered to its revolution around our world? This is not a coincidence. In the grand theatre of the cosmos, coincidences of this scale are virtually impossible. Such perfect timing, maintained over billions of years, cannot be a matter of chance. It must be the result of a physical process, a powerful, patient force that has shaped the moon's behavior, acting like a cosmic brake, slowing its primordial spin until it clicked into this flawless, stable lockstep. The unchanging face of the moon is not a sign of stillness. It is a cosmic crime scene. It is the fossilized evidence of a dramatic gravitational struggle that took place in the dawn of the solar system. To understand that struggle, we must delve into the very laws that govern how objects move and interact across the void. We must begin to think like the pioneers who first deciphered the invisible architecture of the heavens. This is where the story shifts from what is happening to the profound and elegant question of why. For most of human history, the motions of the heavens were a source of wonder, but their causes were a complete mystery. Objects on Earth fell downwards. That was understood. But the sun, the moon, the planets, they seemed to follow a different set of rules entirely. They moved with the precision of a divine clockwork, untroubled by the forces that governed our terrestrial world. The great intellectual leap was the realization that there are no two sets of rules. The same force that causes an apple to fall from a tree is the very same force that holds the moon in its orbit. This was the dawn of celestial mechanics, the beginning of our understanding that the universe is governed by universal laws accessible to reason and mathematics. Thinkers like Johannes Kepler, by painstakingly analyzing decades of observational data, discovered the elegant geometry hidden within the orbits of the planets. They were not perfect circles as had been assumed for millennia, but ellipses, and the planets did not move at a constant speed but accelerated as they drew closer to the sun and slowed as they moved away. This was a universe of patterns of mathematical harmony, but it still lacked a cause, a physical explanation. Then came Isaac Newton. He proposed a radical unifying idea, universal gravitation. Every object with mass in the universe, he suggested, pulls on every other object with mass. This pull, this gravity depends on two things: how massive the objects are and how far apart they are. Suddenly, the cosmos was not a collection of objects following abstract geometric paths. It was a dynamic, interactive system, a web of invisible connections, a gravitational dance of breathtaking scale and complexity. The Earth was not just a platform from which we watch the moon. Our planet is actively pulling on the moon, constantly deflecting it from a straight path into a curved orbit. It's like a cosmic tether holding the moon in our sway. But Newton's law says this pull is mutual. The moon, in turn, is constantly pulling on the Earth. This is not a one-way relationship. It is a partnership. You can feel the moon's gravitational influence every day. Its pull is powerful enough to tug on Earth's vast oceans, creating the rhythmic rise and fall of the tides. The moon is literally stretching our planet, and in that stretching, in that mutual gravitational embrace, lies the key to our mystery. The key to understanding how a once freely spinning world could be slowed, captured, and locked into its perfect synchrony. The forces at play are subtle, acting over immense periods. They are the patient sculptors of the solar system. They take the raw chaos of planetary formation and over billions of years shape it into a state of order, of stability, of seeming perfection. The moon's unchanging face is the ultimate testament to the relentless, inescapable power of gravity. It is a story written not in light, but in force. A story of how a tiny imbalance, a slight bulge in a world's shape, can act as a handle for gravity to grab onto. A handle to torque and twist a celestial body over eons, bleeding away its rotational energy until its spin surrenders to its orbit. We have journeyed from the campfires of our ancestors who saw a face in the sky to the precipice of a profound physical explanation. We have unmasked an illusion and replaced a simple question with a far more compelling one. We now know the moon is spinning, and its spin is locked. The stage is set. The actors, Earth and Moon, are in place. The force gravity has been introduced. Now, we must witness the drama itself. We must reconstruct the events of 4.5 billion years ago and watch as this cosmic ballet was choreographed step by inexorable step. The silent, steady gaze of the moon is about to speak, and it will tell us a tale of its own violent birth and the long, slow process of being tamed by the Earth. The greatest secrets are often hidden, not in what changes, but in what stays impossibly the same. The moon's serene face is the ultimate cosmic paradox, a mask of stillness that conceals a perfectly executed motion, a placid expression that belies a tumultuous history. To truly appreciate this celestial marvel, we must see it not as a static object, but as the end result of a process, a gravitational conversation that has been unfolding for nearly the entire age of our solar system. The ancient observers were not wrong to see it as a constant, but they could never have imagined the dynamic truth that this constancy revealed. They saw a god, a lantern, a calendar. We now see a triumph of physics, a gravitationally locked world, a monument to the patient, unrelenting forces that shape the cosmos. The simple act of looking up at the moon has been transformed. We are no longer just seeing a familiar face. We are seeing the solution to a 4.5-billion-year-old equation. And in the next part of our journey, we will solve that equation together. We will discover the precise mechanism of this celestial lock, a process known as tidal locking. And we will find that this same process is not unique to our moon, but is a common fate for worlds throughout the universe, shaping the destinies of planets and stars in a silent gravitational embrace that stretches across the galaxies. The mystery of the moon's motion is just the beginning. It is our key to understanding a fundamental principle of how the universe organizes itself from the smallest moon to the largest star clusters. The journey into the heart of this perfect hidden dance has just begun. To solve a mystery that unfolds across billions of years, you cannot begin with the moon itself. You must travel back in time to a different world, to a damp English garden in the 17th century, where the cosmos was still a place of divine whim and inscrutable chaos. The heavens were a separate kingdom ruled by their own unknowable laws, while Earth was a terrestrial stage for our own fleeting dramas. An apple falls. The moon hangs in the sky. For nearly all of human history, these two events were utterly disconnected, inhabitants of profoundly different realms of existence. And then a mind appeared that would irrevocably change our perception of everything. Isaac Newton did not simply see an apple fall, he saw in its simple earthward plunge a question of universal significance. What was this invisible tether, this unseen summons from the planet's core, and could it be that this very same influence, this familiar terrestrial pull, reached out far beyond the clouds, beyond the air itself? Could the same mundane force that brings a piece of fruit to the ground be the very thing that holds the majestic moon in its celestial embrace? This was not merely a new idea, it was a profound act of rebellion. It was the demolition of a wall that had stood for millennia in the human mind, a wall separating the earthly from the heavenly. Newton proposed something staggering in its elegant simplicity. He suggested a universal law, a language of attraction spoken by all matter. Every object in the cosmos, he claimed, from the smallest grain of sand to the most colossal distant star, pulls on every other object. This was gravity. Not a unique property of our world, but the invisible architecture of the universe. Suddenly, the moon was not held aloft by mysterious angelic forces or cosmic crystal spheres. It was falling. Right now and in every moment, the moon is plummeting towards the Earth. It is only its tremendous sideways velocity, a perfect and perpetual balancing act, that keeps it from ever reaching us, forever falling around our world in a stable orbit. With this single magnificent insight, the universe transformed. It ceased to be a chaotic theatre of unpredictable events. It became a grand, intricate clockwork governed by precise, discoverable mathematical laws. The cosmos had a code, and for the first time humanity had begun to read it. But within this newfound clarity, this universal principle of attraction, lay a far more subtle and consequential truth, a truth that holds the very key to our moon's silent, unblinking stare. To understand it, we must refine our vision of Newton's great force. Gravity is not a simple, uniform blanket thrown over an object. Its strength is not absolute. It is a negotiation with distance. The closer you are to an object, the more powerful its gravitational summons. The farther away you move, the more that influence wanes its grip, loosening with every kilometer. This seems simple enough, but when applied to a body as vast as our moon, it becomes the engine of a world-altering transformation. Think of the moon not as a single point in space, but as a colossal sphere of rock, thousands of kilometers in diameter. Earth's gravity pulls on this entire sphere, but it does not pull on it evenly. The side of the moon facing us, the near side, is thousands of kilometers closer than the side perpetually turned away from us, the far side. This difference in distance, though small on a cosmic scale, is paramount. The gravitational pull from Earth is measurably stronger on the moon's near side than it is on its distant hidden face. And the moon's very center experiences a pull somewhere in between. Imagine a cosmic tug-of-war with Earth pulling on every single particle of the moon. The particles on the front line feel the strongest tug. The particles at the rear feel the weakest. This differential, this gradient of gravitational influence across the moon's body, is a phenomenon we call a tidal force. It is not a separate power, but a consequence of gravity's own nature. It is a stretching force, a relentless planetary scale compulsion to elongate the moon along the line pointing directly towards our world. This force is a sculptor of worlds, and its work is slow, but its effects are profound. Under the persistent, uneven grasp of Earth's gravity, the moon's very shape is warped. It is subtly squeezed at its poles and stretched at its equator, pulled into a shape that is not a perfect sphere. It becomes a slightly prolate spheroid, like a terrestrial rugby ball or an American football, though the effect is far too subtle for the naked eye to see. Two small bulges of rock and dust are raised on the moon, one on each side. The near side bulge is the most intuitive. It's the portion of the moon pulled most powerfully toward Earth. But a second bulge is formed on the far side as well. This one is not pulled outward so much as it is left behind. Earth is pulling the moon's center away from the far side surface more effectively than it pulls on the far side itself, creating a corresponding distortion. So our moon is not the perfect marble we imagine it to be. It possesses two permanent subtle elevations, two tidal bulges forged by the differential gravity of our own planet. These bulges became the handles, the levers through which Earth would take control of its companion's destiny. They were the key to initiating a slow cosmic dance that would play out over eons, a ballet of torque and friction that would forever arrest the moon's spin. To witness this celestial drama, we must once again travel through deep time. Let us journey back 4 billion years to a younger, more chaotic solar system. The moon is newly formed, a molten sphere of rock still cooling from its violent birth, and it is spinning, not the slow, stately rotation we know today, but a frantic, dizzying pirouette. A single lunar day might have lasted only a few of our modern hours. It was a hyperactive world turning rapidly on its own axis, while it dutifully circled the primordial Earth. But even then, Earth's gravitational influence was already at work. Its tidal forces were already sculpting the young moon, raising those two opposing bulges upon its pliable, cooling surface. Now, a critical complication enters our story. A conflict is born from the moon's own rapid rotation. If the moon had not been spinning at all, those two bulges would have pointed directly at the Earth, a perfect stable alignment. One bulge facing us, one facing directly away. But the young moon was spinning, and spinning much faster than it revolved around our planet. This rapid rotation physically dragged the tidal bulges forward. Imagine the bulges as massive continent-sized mountains of rock. As the moon spun, its own momentum carried these mountains slightly ahead, so they no longer perfectly aligned with the Earth-Moon axis. The near side bulge was no longer pointed squarely at us, but was slightly offset in the direction of the moon's rotation. And in that small, seemingly insignificant misalignment, everything changed. Earth's gravity was now presented with an irresistible opportunity. It was still pulling on the entire moon, but its pull on the nearer, more massive bulge was the strongest. And this bulge was now slightly out of place. Earth's gravity acted like a relentless leash, constantly tugging this leading bulge backward, trying to pull it back into perfect alignment. This was not a straight central pull. It was an off-center, twisting pull. It was a force that didn't just attract, it sought to rotate. In physics, we call such a twisting force a torque. It was a subtle but profoundly effective gravitational brake. Picture a potter's wheel spinning rapidly. Now imagine a gentle, persistent pressure applied to one side. Not enough to stop it at once, but enough to introduce a constant, steady friction. The wheel will inevitably, inexorably begin to slow. This is what our planet did to its satellite. The Earth exerted a continuous gravitational torque on the moon's misaligned bulge. It was a cosmic battle waged in near silence over unimaginable timescales. The moon's rotational momentum fought to keep it spinning freely. Earth's tidal torque worked ceaselessly to slow it down. And in this contest between the moon's spin and Earth's grasp, there could only be one victor. Every single rotation, the Earth stole a tiny fraction of the moon's angular momentum. Each lunar day became infinitesimally longer than the last. The effect was minuscule in any given year or even any given millennium. It was a geological process, not a human one. a change written in the slow language of planetary evolution, but the universe has the luxury of time. For hundreds of millions, then billions of years, this process continued. This gentle but inescapable braking force born from Earth's uneven pull systematically bled the energy from the moon's rotation. The frantic spin of its youth gave way to a more measured rotation. The lunar day stretched from a few hours to 10 hours, then to 100, then 1,000. The moon's pirouette was being quelled, its chaotic energy being disciplined by the unyielding laws of gravitational physics. This process would not stop until a state of equilibrium was reached, a final stable configuration where Earth's gravitational brake would no longer have any effect, and that point would only arrive when the moon's rotation slowed to the exact speed of its orbit around the Earth. When the time it took to spin once on its axis was precisely the same as the time it took to complete one revolution, at that magical juncture the dance would change forever. With its rotation and revolution perfectly synchronized, the tidal bulges would no longer be dragged ahead. They would finally snap into their lowest energy state, a permanent, stable alignment with Earth. The near-side bulge would now point directly at us at all times. The gravitational torque would vanish. The braking would cease. The long war of attrition was over. The Earth had won. It had molded its companion first by stretching its very body, then by using those deformations as celestial handles to arrest its spin. The once frenetic satellite was now tamed, locked into a serene and permanent posture. It was now condemned to forever present only one hemisphere to its planetary master. The dance had found its final, silent choreography, a state we now call synchronous rotation, or more poetically, tidal locking. The mystery of the moon's unblinking gaze was not a mystery of stillness, but the resolution of a dynamic eon-long struggle written in the language of gravity itself. The great lunar mystery, the case of the missing spin, is not a riddle to be solved by looking at the moon. The answer was never etched upon its silent, cratered face. The definitive clue, the force that arrested a world's rotation, has been hiding in plain sight. It has been right here with us all along. The solution is gravity, but not the simple gravity we learn about in school, the gentle tether that keeps the moon in its orbit, preventing it from careening off into the void. This is a different aspect of the force, something more intimate, more invasive, and profoundly more powerful over time. It is gravity as a sculptor, as a brake, as a cosmic hypnotist. To understand its influence, we must first reimagine our planet's pull. You feel it now, a constant uniform presence. But gravity is not a blanket. It is a current. It flows from the center of the Earth, weakening with distance. Every inch, every millimeter you move away from our planet's core, its grasp becomes infinitesimally more tenuous. For us here on the surface, that difference is meaningless. But for the moon, a colossal sphere of rock, 250,000 miles away, this gradient, this slope of gravitational influence, is everything. The side of the moon facing us, the familiar near side, is about 4,000 kilometers closer to Earth than the far side, and so it experiences a slightly stronger gravitational pull. The far side, in turn, is pulled upon more gently. This is the genesis of a profound and world-altering phenomenon. It is the secret behind the tides that wash over our own shores, the ocean waters being pulled and stretched by the moon's own gravity. But what we so often forget is that this is a two-way street. The Earth, being over 80 times more massive than the moon, exerts a far more formidable tidal force on its smaller companion. Our world has been shaping the moon since the moment of its birth. We must now travel back in time over 4 billion years ago to a younger, more violent and unrecognizable solar system. Here, a newly formed moon orbits a newly formed Earth. This primordial moon is not the cold, solid body we know today. It is a world still glowing with the heat of its creation, a sphere of molten and semi-molten rock, pliable and yielding. And it is spinning furiously. Perhaps a lunar day lasted only 5 or 6 hours. The cosmos would have wheeled overhead in a dizzying, frantic blur. This was the moon's inherent primordial momentum, the rotational energy left over from its cataclysmic formation. It was a spinning top, wild and free, but it was not free from the relentless influence of its larger neighbor. The Earth's powerful gravitational gradient began its work immediately. It pulled more forcefully on the moon's near side than its far side, while the moon's core was pulled with an intermediate strength. This differential pull began to stretch the young, malleable moon. It was as if our planet reached out with invisible hands and began to gently knead the substance of its companion world. The perfect sphere was subtly distorted. It was warped into a slightly oblong shape, a prolate spheroid like a rugby ball or an American football, though far less pronounced. 2 bulges were raised on the moon's body, one bulge on the side facing directly toward Earth, pulled outward by the stronger gravitational tug, and another equal bulge on the side facing directly away, left behind by the weaker gravitational influence. These were not tides of water, but tides of solid rock, a planetary scale deformation in the very fabric of the moon. The entire world was elongated along the axis pointing toward our planet. For a time, this changed very little. The frenetic moon continued to spin a lopsided sphere in a fast rotation, its twin bulges fixed in alignment with the Earth. But this state of affairs could not and would not last. Here, the cosmic drama truly begins. We have 2 distinct motions in conflict: the moon's rapid rotation, its spinning on its own axis, and the moon's much slower orbit around the Earth. The key to the mystery lies in the fact that these 2 motions were not yet synchronized. They were out of step. The moon was spinning much, much faster than it was orbiting. Imagine this lopsided, bulging moon spinning on its axis. As it turns, it attempts to carry its tidal bulges along with it. The rock of the moon is not perfectly elastic. It has inertia. There is a friction within its substance, so the bulges do not remain perfectly aligned with the Earth. The moon's fast rotation drags the bulges slightly forward ahead of the direct line between the Earth's and moon's centers. Now you have a spinning, elongated moon with its bulges offset just slightly from their natural position. One bulge is leading just ahead of the point closest to Earth, the other is trailing just behind the point farthest away, and this tiny, seemingly insignificant misalignment was the trigger for a 4-billion-year-long celestial reckoning. It created the most effective braking system in the solar system. Think of the Earth's gravity now pulling on these offset bulges. The leading bulge, the one dragged slightly ahead by the moon's spin, is closer to Earth. The gravitational pull on it is immense, but that pull is no longer perfectly centered. Earth is now tugging back on this bulge, trying to pull it into alignment. It is a relentless, backward-facing torque, a constant twisting force working against the moon's rotation. Simultaneously, the trailing bulge on the far side feels a weaker pull, but this pull is also off-center, yanking it forward slightly again, attempting to bring the moon's elongated axis into alignment. The net result of these 2 gravitational handles was a persistent, unending campaign to slow the moon down. It was a cosmic war of attrition fought with the quietest of forces. Imagine trying to stop a spinning flywheel with your bare hands. The friction generates heat, and the wheel slows down. The same thing happened to the moon. This constant gravitational tugging and pulling on the moon's bulges generated immense friction deep within its interior. The rock flexed and ground against itself on a planetary scale. This process dissipated energy, bleeding it away as heat. The energy being lost was the moon's rotational energy. Its spin was being converted into heat, which then radiated away into space. Millisecond by millisecond, century by century, eon by eon, the moon's rotation was being robbed. The frantic, chaotic spin of its youth began to temper. the celestial dance began to slow, to grow more deliberate. A whisper of a force applied for an eternity became a roar. This gravitational braking was fantastically effective. The lunar day, once perhaps a mere 5 hours long, began to stretch. It became 10 hours, then 20. Then it became as long as a modern Earth day. Then it grew longer, still lasting for hundreds of hours. All the while, the moon continued its stately orbital journey, completing one lap around the Earth in about 27 days. The slowdown was inexorable. The moon was locked in a gravitational arm wrestle with the giant, and there could only ever be one outcome. Its spin continued to decrease its angular momentum, bleeding into the void, until a truly remarkable moment was reached. A moment of celestial surrender, a moment of perfect equilibrium. The moon's rate of rotation slowed until it precisely matched its rate of orbit. Suddenly, the braking stopped. The war was over. Once the moon's spin took exactly as long as its orbit, its tidal bulges were no longer dragged ahead. The elongated axis of the moon now pointed consistently, stably at the Earth. The gravitational handles that Earth had used to slow it down vanished. The torque dropped to zero. There was no longer an offset for gravity to grip. The moon had found its lowest energy state, a stable resonance. It had become tidally locked. From this moment forward, its fate was sealed. It would rotate on its axis one single time for every single orbit it made around our world. A perfect one-to-one synchronization. And that is the solution. That is the reason we only ever see one face of the moon. It is not because the moon fails to spin. It spins magnificently, a complete rotation for every orbit. But because its spin and its orbit are now perfectly harmonized, the same hemisphere is perpetually left facing our world. The once hidden far side is now permanently turned away from our gaze. Think of a dancer in the middle of a room representing the Earth. You, representing the moon, begin to walk a circle around them. If you simply walk without turning, the dancer will see your front, then your side, then your back, then your other side. But if you want to keep facing them at all times, you must slowly pivot as you walk your circle. By the time you complete one full circle, you will have also spun once. That is the motion of our moon, a slow, deliberate, captured pirouette. The illusion of stillness is born from this perfect synchronicity. The face we see with its familiar seas of basalt and bright highlands is the face that was shaped by Earth's relentless gravitational braking. It is the hemisphere that happens to contain the leading tidal bulge, now frozen in a permanent salute to our planet. This process is not unique to our moon. It is a universal phenomenon, a fundamental consequence of gravity. Throughout the solar system and beyond, we see its signature. Most of the major moons orbiting Jupiter and Saturn are tidally locked. The planet Mercury, scorched by the Sun's immense gravity, is locked in a more complex 3-2 resonance, spinning 3 times for every 2 orbits it completes around its star. Even Pluto and its largest moon, Charon, have taken it a step further. They are mutually tidally locked. Not only does Charon always show the same face to Pluto, but Pluto also always shows the same face back to Charon. They are fixed in a permanent gravitational embrace, 2 worlds staring at each other across the void for all eternity. It is the ultimate fate for any 2 bodies orbiting closely for long enough. And the story is not quite over, even for us. This gravitational conversation continues to this day. Just as the Earth raised tides on the moon raises tides on Earth. Our planet's faster rotation drags our ocean tides ahead, and the moon in turn pulls back on them. This interaction is having the opposite effect. It is gently breaking the Earth's rotation. Our day is getting longer by about 2 milliseconds every century. It is an imperceptible change on human timescales, but over geological ages it is a profound transformation. In the time of the dinosaurs, an Earth day was only about 23 hours long. The energy that the Earth loses from its spin is transferred to the moon's orbit. As a result, the moon is gradually moving away from us. Every year it drifts about 1.5 inches further into space. A cosmic retreat measured with laser precision. The silent, unchanging face of the moon is a lie. It is the face of a world in motion, the result of a dynamic history. It is a monument to the subtle, inescapable power of gravity, a force that can reach across 250,000 miles of vacuum and arrest the spin of an entire world. So when you next look up at that silver disk in the night sky, see it not as a static sleeping object, see it as the survivor of a 4 billion-year tug of war. Its serene face is a mask concealing a past of unimaginable friction and heat. It is a cosmic pendulum that has finally come to rest. It is not still, it is captured. The bond between Earth and Moon seems eternal, a perfect and finished portrait, a silent silver sphere forever gazing upon its blue marble. But this tranquility is an illusion, a masterpiece of cosmic misdirection. The story is not over. The equilibrium we perceive is not an endpoint. It is an ongoing negotiation, a dynamic and relentless exchange. And in this cosmic transaction, our world is slowly paying a profound price. The moon, that placid face in our night sky, is a thief, a gentle gravitational thief stealing moments from your future. Every single day it plunders a tiny, imperceptible fraction of our world's spin. This isn't a theoretical concept. It is the engine behind our tides. Twice a day, the oceans heave, rising and falling in a rhythm as old as life. We see the water move, but we miss the true story happening beneath. The moon's gravitational pull is not uniform across our planet. It tugs more forcefully on the side of Earth facing it. This differential pull stretches our world, especially our fluid oceans. It creates 2 bulges of water, 2 tidal swells on opposite sides of the planet. One bulge is pulled directly toward the moon. The other is formed on the far side where the Earth itself is pulled away, leaving the water there to lag behind, creating a corresponding swell. Now here is the secret to the grand celestial larceny. Our planet spins on its axis far more rapidly than the moon orbits around us. Earth completes a full rotation in just 24 hours. The moon requires more than 27 days to complete its journey. Because of this mismatch in speed, our spinning world drags those tidal bulges. It pulls them slightly ahead of the moon's position in the sky. Imagine our planet as a spinning top and the oceans as a loose cloak. The top spins quickly and the cloak is dragged along slightly askew. Those 2 massive bulges of water, each weighing trillions of tons, are not directly under the moon. They are always slightly ahead of it, leading the dance. And the moon, ever present, pulls back on them. Its gravity latches onto that leading bulge, trying to tug it back into alignment. This constant backward tug acts as a brake. A colossal, invisible brake pad pressed against the surface of our spinning world. It is the friction between the ocean floor and the vast mass of tidal water, a relentless drag fighting against the momentum of our planet's rotation. This gravitational handshake is not a gentle one. It dissipates an enormous amount of energy, warming the oceans ever so slightly. But its most significant consequence is written into the length of our day. The Earth is slowing down. Our planet's spin is gradually, inexorably decelerating. The cosmic metronome that dictates our lives is winding down. The change is infinitesimal on a human timescale. So small you could never feel it, never notice the shift from one sunrise to the next. The length of a day is increasing by a mere 17 microseconds each year. A microsecond is a millionth of a second. It seems like nothing, a rounding error in the grand calculation of celestial mechanics. But the universe does not deal in human lifespans. It deals in deep time. And over geological epochs, these stolen microseconds accumulate into hours. They build into a profound alteration of our world's fundamental rhythm. We have found the proof of this ancient theft etched into the very bones of the Earth. Geologists have become detectives searching for ancient clocks. They found them in the delicate layers of fossilized corals. Corals, like trees, lay down daily and yearly growth bands. By analyzing corals from the Devonian period 400 million years ago, scientists made a stunning discovery. Back then, a year on Earth still had the same duration, the time for one orbit. But the number of days within that year was not 365. It was closer to 400. The days were shorter. The Earth was spinning faster. A day in the time of the first amphibious creatures lasted only 22 hours. The Moon was closer then, its braking effect even more pronounced. We can cross-reference this with even older evidence. Banded iron formations, sedimentary rocks laid down billions of years ago. They show tidal patterns, ancient rhythms of sediment deposition. These patterns whisper of a primordial Earth with days as short as 18 hours. History, too, provides its own clues to this cosmic slowdown. Astronomers have painstakingly analyzed ancient eclipse records. Observations of solar and lunar eclipses meticulously recorded by Babylonian scribes, ancient Chinese astronomers, and Greek scholars. They noted the exact time and place an eclipse occurred thousands of years ago. When we run our modern orbital models backward in time, a discrepancy appears. The eclipses should have happened in different places at different times. The ancient cities where they were observed should have been rotated out of the shadow. Unless the Earth was spinning faster back then. Unless the days were shorter, allowing those locations to be in the right place. The ancient tablets and scrolls are a perfect match. They confirm the geological evidence with human testimony from across the ages. Our ancestors unknowingly were recording the slowing pulse of our world. This deceleration is a fundamental truth of our planet's past and its future. But this is only half of the transaction. There is a law in the universe more fundamental than almost any other. The conservation of angular momentum. In a closed system like the Earth and Moon, momentum cannot simply disappear. It must be conserved. It must be transferred. The rotational energy that our Earth is losing is not vanishing into the void, it is being given away. And the recipient of this colossal offering of energy is the Moon itself. The Moon's gravitational drag on Earth's tidal bulges does two things at once. It slows the Earth's spin, but it also gives the Moon a tiny gravitational push forward. That leading bulge of water which the Moon is pulling back on simultaneously pulls the Moon forward in its orbit. This constant gentle acceleration is like an unending push on a cosmic swing. It boosts the Moon, it energizes its orbit. And what happens when you give an orbiting body more energy? It moves into a higher orbit. It spirals away. The Moon is escaping. Right now, at this very moment, our celestial companion is drifting away from us. The rate of its departure is stately, almost poetic in its subtlety, 3.8 centimeters per year, roughly the same speed at which your own fingernails grow. It is a separation so slow, so patient it seems utterly insignificant. But again, the cosmos does not care for our perception of time. This gradual retreat has been happening for billions of years. When the Moon first formed, it loomed monstrously in our primordial sky. It was perhaps 15 times closer than it is today. It would have appeared immense, a terrifying and beautiful spectacle. A day on Earth was a dizzying blur, perhaps only 6 hours long. The tides were unimaginable, colossal waves scouring the barren continents. Over the eons, as Earth's spin slowed, that energy was pumped into the Moon's orbit, pushing it farther and farther away into the calmer skies we know today. This process continues a silent and irreversible divorce. We have measured this retreat with breathtaking precision. During the Apollo missions, astronauts placed retroreflectors on the lunar surface, mirrors designed to bounce back powerful laser beams fired from Earth. For decades, observatories have been firing these lasers at the moon and timing the return journey of the photons down to the nanosecond. This lunar laser ranging experiment confirms the slow escape. It measures the widening gulf between our worlds with millimeter accuracy. The evidence is undeniable. The two halves of the equation balance perfectly. The momentum lost by the slowing Earth is precisely what is gained by the receding Moon. It is a single magnificent interconnected system, a gravitational dance of breathtaking elegance and scale. This ongoing separation has consequences for our distant future. One of the most spectacular celestial events visible from Earth is a total solar eclipse, a moment when, by a sublime cosmic coincidence, the Moon is at the perfect distance to appear precisely the same size as the Sunday, allowing it to block the Sun's face, completely revealing the magnificent corona. This alignment is not permanent. It is a fleeting gift of our current epoch. As the Moon continues its slow march away from us, it will appear smaller and smaller in our sky. In the distant future, hundreds of millions of years from now, it will become too small to ever completely cover the Sunday. Future inhabitants of this planet will look up and see only annular eclipses, a ring of fire, but never the total breathtaking darkness we can witness. The age of total solar eclipses is a temporary window in Earth's long history, and our generation is privileged enough to live within it. This grand, intricate ballet of tidal forces is not a private affair. This gravitational dialogue between a planet and its moon is not unique to us. It is a universal language spoken throughout the cosmos. Wherever there is mass and motion and time, this process unfolds. Look to the gas giants, the colossal rulers of our outer solar system. Jupiter, a world so massive it could swallow all other planets combined. It is orbited by a court of dozens of moons. Its four largest, the Galilean moons, are worlds in their own right, and every single one of them is tidally locked. Io, Europa, Ganymede, and Callisto all keep one face perpetually turned, forever gazing upon the swirling, banded face of their gargantuan parent. The tidal forces exerted by Jupiter are almost beyond comprehension, so immense that the locking process happened far more quickly than it did for our moon. The friction and flexing within these moons was extreme. It didn't just synchronize their rotation, it fundamentally reshaped them. On the moon Io, the closest of the four, this tidal squeezing is relentless. Jupiter's gravity pulls it, and the other moons pull it back. It is constantly stretched and compressed like a cosmic stress ball. This process generates an incredible amount of heat through internal friction. So much heat that Io is the most volcanically active body in the entire solar system. Its synchronized face is a hellscape of sulfur plains and erupting volcanoes, a direct and violent consequence of the same forces that govern our tides. Farther out on Europa, those same tidal forces are thought to have melted its interior, creating a vast liquid water ocean hidden beneath a shell of ice, an ocean kept warm and moving by the constant gravitational kneading from Jupiter. Tidal locking here may have created one of the most promising places to search for life. The same principle is at work, but the results are profoundly different. Journey outward to the ringed jewel of our system, Saturn. Its family of moons is a dizzying array of ice and rock, from the giant Titan with its methane rivers to tiny cratered Mimas. They too are overwhelmingly tidally locked. Enceladus, a tiny moon of shimmering ice, has its rotation bound to its orbit, and like Europa, the tidal flexing from Saturn maintains a subsurface ocean, an ocean that erupts into space through giant geysers at its south pole. The silent, synchronized face is a mask for a dynamic liquid interior. Tidal locking is not merely a curiosity, It is a primary engine of planetary evolution. It dictates the energy, the heat, and the potential for life in these distant realms. But the most perfect example of this process lies at the desolate edge of our system. In the cold, dark domain of Pluto, Pluto is orbited by its enormous moon Charon. Charon is so large relative to Pluto, almost half its diameter, that many astronomers consider them a binary dwarf planet system. Here, the gravitational conversation has reached its final logical conclusion. Not only is Charon tidally locked to Pluto, showing it only one face, Pluto is also tidally locked to Charon. They are mutually perfectly synchronized, a double tidal lock. Imagine standing on the surface of Pluto, on the side facing Charon. Charon would hang in the sky motionless. It would never rise. It would never set. It would simply hover in the same spot, day after year, century after century. And from the surface of Charon, Pluto would do exactly the same. They are frozen in a gravitational embrace, two worlds facing each other for eternity. A silent celestial standoff across a mere 12,000 miles of space. This is the ultimate fate of the Earth-Moon system. In the unimaginably distant future, billions of years from now, the Earth's rotation will have slowed so much that its day will match the Moon's orbit. At that point, one Earth day will last for over a month of our current time. Our world will finally be tidally locked to the Moon, just as Pluto is to Charon. The Moon will hang stationary in the sky over one half of our planet. The other hemisphere will never see it at all. The great cosmic theft will be over an equilibrium finally achieved. But the reach of tidal forces extends far beyond planets and their moons. It operates on the most magnificent scale imaginable. It governs the interactions between stars themselves. Throughout the galaxy, countless stars exist in pairs or multiples. Binary star systems, two suns orbiting a common center of gravity. If these stars are close enough, the same tidal forces that warp our oceans can warp the very fabric of the stars themselves. Gravity stretches these giant spheres of incandescent plasma into egg shapes. Tidal bulges of stellar fire trillions of miles high. The drag and friction created by these stellar tides is immense, and over millions of years they can force the stars into a state of tidal lock. Two suns each presenting only one hemisphere to the other as they dance. We see this happening across the cosmos. It is a fundamental process of stellar evolution, and this principle dictates the nature of worlds beyond our own solar system. In our search for exoplanets, we have found thousands of alien worlds. Many of them are so-called hot Jupiters, gas giants orbiting perilously close to their parent stars, closer than Mercury orbits our own Sunday. For these worlds, the tidal forces are astronomical. They are almost certainly tidally locked. This creates planets of the most extreme contrasts imaginable. One side, the star-facing side, is locked in perpetual scorching daylight. Temperatures can rise high enough to vaporize rock. The other side, the dark side, is trapped in an endless frozen night. Winds of supersonic speed may howl across the terminator, the twilight zone, the line separating the inferno from the abyss. The habitability of any world is profoundly affected by this locking. A tidally locked rocky planet in the habitable zone of a red dwarf star would be a world of eternal sunrise on one edge and eternal sunset on the other. Could life arise in that thin sliver of perpetual twilight, this ancient, patient force that holds our moon's face toward us, is one of the key questions in our search for life elsewhere in the universe. So we return to that silent, familiar face in our night sky. That constant, unchanging gaze is not a sign of stillness or simplicity. It is a testament to the most powerful, patient, and persistent force in the cosmos. The story of the moon's spin is the story of gravity itself, a story of energy exchanged over impossible gulfs of space and time. It is a narrative written in the tides, in ancient fossils, and in the light of distant suns. The quiet face of our moon is a reminder that nothing is truly static, that we are part of a dynamic, evolving system. A system where our days are lengthening and our moon is slowly saying goodbye. A cosmic ballet that continues second by second as our world continues its long, slow spin. We began this journey with a deceptively simple question, a cosmic riddle hiding in plain sight. Why doesn't the moon spin for millennia we have watched it glide across our sky? A constant companion, a silent, unblinking observer. It has always shown us the same serene, familiar face. A face pockmarked with ancient scars and vast dark seas. This constancy felt like a fundamental truth of the universe, a cosmic stillness in a universe of perpetual motion. But we have peeled back the layers of this celestial illusion. We have followed the clues from ancient observations to the revolutionary insights of gravitational physics, and now we arrive at the strange, beautiful truth. The final satisfying answer to our question is this: the moon does spin. It spins perfectly, elegantly, and with profound purpose. It completes exactly one rotation on its axis in the precise time it takes to complete one orbit around us. This is not a coincidence. It is not a lucky celestial alignment. It is the final act in a gravitational drama 4 billion years old, a drama of immense forces of tidal friction and of a universe that always eventually seeks balance. The moon's placid face is not a sign of inactivity. It is the very signature of its deep and ancient connection to Earth. It is the result of a cosmic negotiation, a gravitational pact. Imagine two dancers locked in an intricate embrace. At first, one might be spinning faster, a blur of motion, but as they move together, their hands clasped, their energies merge. The faster dancer slows, transferring momentum to their partner. Their movements begin to synchronize, to find a common rhythm, until finally they are moving as one, a single harmonious system turning in perfect time. They face each other for the remainder of the dance. This is the story of the Earth and the Moon. Our world and its satellite are bound in this gravitational waltz. The Moon, born spinning furiously from the chaos of the early solar system, was gradually inexorably slowed by the Earth's immense gravity. The tidal bulges we learned about, those slight deformations in its rock, acted as a cosmic brake, a handle for Earth's gravity to grip. Over eons, this relentless gravitational friction bled the moon's spin away. It was a slow, majestic process of energy dissipation, a transfer of angular momentum that altered both worlds. The moon's rotation slowed, and in exchange its orbit expanded. It began to drift away from us, a process that continues today. A few centimeters every year, the price of this ancient equilibrium. So when we look up at that unmoving face, what are we truly seeing? We are not seeing a static, dead world. We are witnessing the final stable pose in a cosmic ballet. We are seeing the inevitable outcome of celestial mechanics, a state of perfect resonance of synchronous rotation. The strange truth is not that the moon fails to spin. The strange truth is that it has achieved a kind of perfection, a dynamic moving stillness that has profound implications not just for our sky, but for countless worlds across the galaxy. This state, this synchronous lock, is more than just an elegant curiosity. It represents a fundamental principle of cosmic physics. The universe, in its grand and unhurried way, is profoundly efficient. It is always seeking the path of least resistance. It is always settling towards states of lower energy. Think of a pendulum pulled far to one side and released. At first, its motion is wild, energetic, swinging high and fast. It possesses a great deal of potential energy, a store of motion. But with every swing, air resistance and friction at its pivot steal a tiny fraction of that energy, bleeding it away as heat. The swings become smaller, calmer, more measured. Eventually, the wild oscillations cease entirely. The pendulum settles into its lowest possible energy state. hanging perfectly still in perfect equilibrium with gravity. The early Earth-Moon system was like that wildly swinging pendulum. The Moon possessed a huge amount of rotational energy, a furious spin left over from its violent birth. Earth's gravity, pulling on the Moon's tidal bulges, acted as the cosmic friction, the drag on the system. The continuous stretching and squeezing of the Moon's interior, a process known as tidal flexing, generated immense heat. This was the pendulum's energy being bled away into the void. Over countless millennia, the planet-sized engine of the Moon was kneaded and flexed by Earth's relentless tidal grasp. Its primordial spin energy was converted into thermal energy, radiating away and forever lost to the system. The Moon was literally heated from within by this gravitational massage, a process that may have contributed to its early volcanism. As this energy was lost, the Moon's rotation had no choice but to slow. It was a one-way street, a journey toward a calmer state. It could never spontaneously speed up again. The system was marching inexorably toward its gravitational destiny. And what is that destiny? It is the state of minimum energy dissipation, the point at which the gravitational friction becomes negligible. That state is achieved only when the Moon stops fighting the pull, when it stops trying to rotate at a different speed than its orbit, when it presents the same face to the Earth at all times. In this synchronous configuration, the tidal bulge raised by Earth is always aligned directly with our planet. The gravitational grip no longer has to drag the bulge back into place. The cosmic brake is released. The friction stops. The system has found its quiet point, its gravitational resting place. It is the cosmic equivalent of the pendulum hanging still. This is why synchronous rotation is not a cosmic fluke. It is the default, the expected outcome for any moon orbiting close to its planet. It is a universal law of celestial mechanics written in the language of energy. The universe is not just stranger than we imagine. It is in some ways more elegantly simple. It follows rules of efficiency that govern everything from a falling apple to the dance of worlds. The Moon's steady gaze is a testament to this cosmic tendency, a tendency towards stability, harmony, and the lowest possible energy state. It is a profound lesson in celestial patience, a silent orbital sermon on the power of time and gravity to tame even the most chaotic beginnings into a final tranquil order. The Moon is not sleeping, it has simply found its peace. And once you understand this principle, you begin to see it everywhere. The cosmic handshake between the Earth and Moon is not unique. It is a pattern repeated over and over throughout our solar system, and likely throughout the countless star systems beyond. Look to the gas giants, the colossal rulers of the outer solar system. Jupiter, a world so massive it could swallow all other planets, is attended by a court of more than 90 moons. Its four largest, the Galilean moons, are worlds in their own right, and every single one of them, volcanic Io, icy Europa, Ganymede, and Callisto, is tidally locked to Jupiter. They each keep one hemisphere perpetually turned toward the striped face of their king. Their own furious primordial spins were long ago sacrificed at the altar of Jupiter's monumental gravity. Saturn, the ringed jewel, tells the same story. Its giant moon Titan, a world with a thick atmosphere and methane seas, is in a perfect synchronous rotation. So are Dione and most of its other significant satellites. They are all held in this gravitational embrace, each one a testament to the inescapable power of tidal forces. The farther we look, the more common the phenomenon becomes. Uranus and Neptune, the distant ice giants. Their major moons follow the same celestial rule. This is not a series of independent coincidences. It is the signature of a fundamental physical law at work, a law that sculpts the motion of entire planetary systems. But perhaps the most extreme and poetic example of this process lies at the very edge of our solar system in the Kuiper belt. Here we find the dwarf planet Pluto, and its largest moon, Charon. Pluto and Charon are not just a planet and its satellite. They are a true binary system, a celestial couple. Charon is so large relative to Pluto, about half its diameter, that its gravitational influence is immense. Just as Pluto's gravity slowed Charon's spin over billions of years, Charon's gravity exerted the same force back on Pluto. It was a mutual process of tidal breaking. Today, they have reached the ultimate state of gravitational equilibrium. Both Pluto and Charon are tidally locked to each other. They are in a state of double synchronous rotation. Pluto always shows the same face to Charon, and Charon always shows the same face to Pluto. If you could stand on one, the other would hang motionless in your sky, a silent, unmoving sentinel forever fixed in one position. They are locked in a perfect cosmic standstill, two worlds trapped in a perpetual silent gaze across the void. It is the ultimate expression of tidal physics, the final quiet destination for any two bodies orbiting closely. From our own moon to the moons of the giants to this distant binary pair, the story is the same. Gravity, given enough time, demands synchronization. It tames the chaotic spins of newborn worlds. It forges a deep and unbreakable connection between them. The silent face of our moon is not an anomaly. It is a member of a vast cosmic family, a family of worlds that have surrendered their rotational independence for a more stable, more intimate, and everlasting dance. This understanding, born from a simple question about our own moon, has become one of the most critical tools in a brand new quest: the search for life beyond Earth. For millennia, we have wondered if we are alone in the universe. Now, for the first time in history, we have the means to find out. Our telescopes can detect planets orbiting distant stars. Thousands of these exoplanets have already been discovered. Each one is a potential new world, a new cradle for life. But our knowledge of tidal locking forces us to rethink what these worlds look like and where we might expect to find life. The most common type of star in our Milky Way galaxy is not like our Sun, it is the red dwarf. These stars are smaller, cooler, and far more numerous than Sun-like stars. They make up perhaps 80% of the stellar population. If life is common, it may very well be found orbiting a red dwarf. But there is a catch. Because these stars are so dim, a planet would need to orbit very close to receive enough warmth for liquid water to exist on its surface. It would have to be in a tight, fast orbit much closer than Mercury is to our Sun, and as we have just learned what happens to a body in a close orbit, it becomes tidally locked. It is an almost unavoidable consequence of the physics involved. This means that the vast majority of potentially habitable planets in our galaxy could be synchronous worlds, worlds that do not have a normal cycle of day and night. Imagine such a planet. One hemisphere is locked in perpetual scorching daylight. Its star hangs forever at the zenith, a blistering, unmoving eye. The surface here could be a desiccated, superheated wasteland. The other hemisphere is trapped in an endless frozen night, a realm of absolute darkness and unimaginable cold. Without the light and warmth of its star, any atmosphere would freeze solid, falling as nitrogen snow onto a landscape of eternal ice. This is the eyeball planet hypothesis, a world with a hot spot on one side and an ice cap on the other. At first glance, it seems like a profoundly hostile environment for life. How could life survive in a world of such extreme contrasts? A planet with a permanent sunburn and a permanent frostbite. But nature and the universe are often more creative than we expect. The key may lie in the border between these two brutal extremes. There would be a ring around the planet, a sliver of permanent twilight, a zone we call the Terminator. Here the star would hang forever on the horizon, casting long shadows, bathing the landscape in an eternal sunrise or sunset. In this twilight zone, temperatures could be moderate, potentially just right for liquid water to flow. Perhaps great rivers fed by melting ice from the dark side could flow toward the heat of the light side, creating fertile valleys. If the planet had a thick enough atmosphere, powerful winds would constantly circulate, carrying heat from the day side to the night side, moderating the temperatures. This could create a broad, habitable band across the planet's surface. Life on such a world would be utterly alien to us. Plants might evolve to be black or red to absorb the dim, ruddy light. Animals would never know a rising or a setting sun. Their entire biology would be adapted to a constant directional light source. The concept of a day would be meaningless. Tidal locking presents a challenge, but it also presents a possibility. A different kind of habitable world unlike anything in our own solar system. And what of the moons orbiting these planets? Tidal forces would not just lock them, they would need them. Just as Jupiter's gravity flexes its moon, Europa, a gas giant in a red dwarf's habitable zone, could do the same to its moons. This tidal flexing could generate enough internal heat to maintain vast liquid water oceans beneath a shell of ice. These subsurface oceans would be shielded from the red dwarf's violent flares. They would be dark but warm and potentially rich in chemical nutrients. It is a tantalizing thought that the very same force that holds our moon in its steady gaze could be the engine that powers hidden habitable oceans across the galaxy. The search for life is no longer just about finding another Earth. It is about understanding the incredible diversity of worlds the cosmos can create. And the quiet, persistent truth of tidal locking is one of the most important chapters in that ever-expanding storybook. It has transformed our vision of what a living world might look like. And it all began with us here on Earth, looking up and wondering about the silent, unchanging face of our moon. Our journey from a simple earthly perspective to the frontiers of astrobiology reveals a profound truth about science. Every question, no matter how small, can be a doorway to a larger universe. Understanding the forces that govern our own cosmic backyard is not merely an academic exercise. It is an essential prerequisite for our future as a spacefaring species. The principles of tidal physics, of orbital resonance and gravitational stability are the fundamental rules of the road for navigating the solar system. When we plan a mission to establish a base on the moon, we must account for its synchronous rotation. It means a lunar day lasts for 2 Earth weeks. Engineers must design habitats and power systems that can withstand 14 days of continuous harsh sunlight, followed by 14 days of deep cryogenic darkness. The same force that locked the moon in place creates our biggest challenge. When we send probes to orbit the moons of Jupiter or Saturn, we are sending them into a complex web of gravitational interactions. Understanding tidal forces allows us to predict their orbits with precision. We can even use the gravity of these moons to slingshot our spacecraft, saving fuel and time on their long journeys into the outer darkness. This knowledge is practical. It is powerful. It is the difference between success and failure in the unforgiving environment of space. The story of the moon's spin is more than just a piece of trivia. It is a foundational lesson in how the cosmos works. It teaches us that things are rarely as they seem, that stillness can be a form of perfect motion, and that the universe is bound by subtle, inescapable laws. We began by looking up at the moon, a familiar, comforting presence. We end by seeing it as a key that has unlocked a deeper understanding of our own planet's past, the workings of our solar system, and the potential for life on worlds we have yet to discover. The moon no longer holds its secret. It has shared with us the story of its long, slow dance with the Earth, a story of gravity time and the inevitable pull toward equilibrium. And in that story we find our own. A species that has learned to read the celestial text, to decode the motions of the heavens, and to ask the questions that lead us step by step outward into the grand, silent and spinning cosmos. So we return to where our journey began, Under the silent, watchful gaze of the moon, it hangs there in the velvet darkness, a familiar silver coin, a constant companion on our planet's lonely voyage through space. For millennia we looked up and saw a face that never changed. A tranquil, static portrait etched against the tapestry of the stars. And we asked a simple, almost childlike question: why doesn't it spin? We thought we were asking about an absence of motion, a celestial anomaly, a world that had forgotten how to turn. But the truth we uncovered was far more profound, more elegant. We were not witnessing stillness at all. We were watching the perfect culmination of a 4-billion-year-old dance, a gravitational ballet of such exquisite precision that the moon's spin is perfectly, immaculately synchronized. With its journey around our world, it does spin, once for every single orbit, a cosmic secret hidden in the most obvious of places. This revelation was not found in a single flash of insight. It is a story woven across generations, a quiet saga of sleepy scientists and patient observers. Think of the earliest stargazers wrapped in animal skins, lying on their backs on ancient plains night after night. They were the first to map its phases, to trace its steady arc. They saw the same seas of tranquility, the same craters of impact, and they encoded this constancy into their myths, their gods, their calendars. They knew the moon's face was a permanent fixture. Even if they could not yet articulate the reason, theirs was the first chapter, a story written in wonder. Centuries unfold like pages in a great cosmic text. The question lingered, a subtle dissonance in the music of the spheres. Then came minds that began to see the universe not as a divine stage, but as a grand, intricate machine governed by universal laws. They built telescopes of brass and polished glass, and pointed them upwards, peeling back the veil of the heavens. They saw that Jupiter had its own moons dancing in attendance, that Venus showed phases just like our own celestial partner. The old certainties began to crumble. The Earth was dethroned from the center of everything, and the stage was set for a new kind of understanding. Imagine Isaac Newton not under an apple tree but by a window at night, staring at that same distant silvered orb. He gave us the language to finally speak with the cosmos, the universal law of gravitation. He realized the force that pulls an apple to the ground is the very same force that holds the moon in its orbit, a continuous invisible tether stretching across 250,000 miles of void. In his equations, the seeds of our answer were sown. He showed us that these two worlds were not separate entities. They were locked in a gravitational dialogue, a conversation of mass and distance. But it was another scientist less famous who pursued the subtler clues. George Darwin, the son of the great naturalist Charles Darwin. He was not a man of grand voyages to distant islands. His explorations took place in the quiet solitude of his study. With pages of dense, complex calculations, he wondered about the long-term consequences of this gravitational torque. He focused on the tides, the daily breath of our planet's oceans, the relentless rise and fall of the sea pulled by the moon's presence. He saw this was not a gentle, frictionless process. It was a source of immense, planet-scale friction. The moon's gravity pulls on Earth's oceans, creating a bulge of water. But the Earth spins much faster than the moon orbits, so our planet's rapid rotation drags this tidal bulge ahead of the moon. This displaced mass of water then pulls back on the moon. It's a subtle but relentless gravitational tug, always one step ahead. This forward pull acts like a cosmic accelerator. Gently, infinitesimally, it coaxes the moon into a higher orbit. Even now, the moon is spiraling away from us at the leisurely pace of about 1.5 inches per year, the same rate at which your fingernails grow, a silent, imperceptible retreat into the cosmic deep. Darwin realized this process had a necessary consequence. a cosmic transaction of energy governed by inviolable laws. If the moon was gaining orbital energy, the Earth had to be losing it. The relentless friction of the tides sloshing against continents was acting as a brake on our planet's rotation. Our days are getting longer moment by infinitesimal moment. When the dinosaurs roamed the Earth, a day was only 23 hours long. The moon was closer then, a larger, more menacing presence in the sky. The tides were more ferocious, a testament to that proximity. Darwin had uncovered a history written not in stone but in motion, a cosmic pendulum swinging down through geologic time. He then turned his gaze back to the moon. He reasoned that this gravitational conversation must be a two-way street. Just as the moon raises tides on Earth, the Earth raises tides on the moon. Not of water, for the moon is dry and barren, but of solid rock, a subtle bulge in the very crust of the moon pulled by Earth's immense gravity. In its distant youth, the moon spun much faster than it does today, a wild, chaotic tumbling through the void. But the Earth's gravitational pull latched onto that rocky bulge, and just like the tides breaking the Earth's spin, this relentless tug acted as a brake on the moon's rotation. Over hundreds of millions of years, it bled away the moon's rotational energy, slowing it down, taming its wild spin, until it reached a point of perfect, stable equilibrium, the point where its rotation period exactly matched its orbital period, the state we now call tidal locking. This wasn't a sleepy scientist's idle speculation. It was a profound deduction about the nature of gravity and time. A story of how two worlds sculpted each other across the eons. Our planet's spin slowed, its days lengthened. The moon's spin was arrested, its retreat began, and its face became forever fixed towards its gravitational master. This is the state of minimum energy, the final resting pose in this cosmic dance. It is not an absence of motion. It is the ultimate expression of gravitational harmony. A quiet, stable state that countless worlds across the universe will eventually find. We confirmed this story with astounding precision in the modern age. We placed mirrors on the moon's surface, a legacy of the Apollo missions, and from Earth we fire powerful laser beams at them, timing the return journey of photons down to the nanosecond. This lunar laser ranging allows us to measure the moon's distance with a precision that can detect a change of millimeters, and we have watched it, year after year, spiraling away. Exactly as George Darwin's patient calculations predicted, the sleepy scientists were right. Their quiet whispers of theory have been confirmed by a thundering chorus of empirical, undeniable fact. The simple question of the moon's spin has unraveled the 4 billion-year-old shared history of our planet and its satellite. But the story does not end here in our own celestial backyard, because the principles we have unearthed are not local, they are universal. The physics that locks our moon into its silent stare is the same physics that choreographs motion across the entire cosmos. It is a fundamental thread in the deep interconnected fabric of reality. Look to Pluto and its largest moon, Charon, out in the frozen twilight of the Kuiper Belt. These two worlds are not just tidally locked, they are mutually tidally locked. Charon presents the same face to Pluto forever, and Pluto presents the same face back to Charon. If you stood on one, the other would hang motionless in the sky, a permanent, unmoving sentinel. They are frozen in a gravitational embrace of perfect symmetry, the final inevitable state for any two bodies orbiting so closely for so long. This phenomenon of tidal locking is not confined to planets and their moons. It scales up, echoing through ever grander cosmic arenas. We see stars, giants of incandescent plasma, orbiting each other in tight, blisteringly hot binary systems. Many of them are also tidally locked, vast spheres of burning gas, their rotations captured, their very shapes distorted into teardrops by the immense gravity of their partners. They pull stellar material from each other in glowing streams, a violent, beautiful testament to the power of tidal forces, the same forces that gently move our oceans can rip apart the surfaces of suns, and the scale continues to expand to a place of unimaginable grandeur. Look between the galaxies. When two galaxies, great islands of billions of stars, draw close to one another, their mutual gravity begins a titanic struggle. The same tidal forces that break a planet's spin are magnified a trillion-fold. They stretch and distort the galactic spirals, pulling out vast sweeping arms of stars and gas, enormous luminous structures we call tidal tails, stretching for hundreds of thousands of light-years across the intergalactic void. These are cosmic crime scenes, evidence of gravity's awesome power. Within these streams, gas clouds collapse, igniting furious bursts of star formation. Something impossible is born. New stars, new worlds created from the wreckage of galactic tides. All of this cosmic drama, this creation and destruction, is governed by the same fundamental principle, the same physics that dictates the quiet, constant gaze of our own moon. Our moon's motion is not a local curiosity. It is a window, a key that unlocks one of the most powerful and pervasive forces in the universe. And now this key is unlocking the secrets of worlds beyond our own. As we turn our most powerful telescopes to distant stars, we are discovering thousands of exoplanets, worlds orbiting other suns, each a potential abode for life. And the quiet truth of tidal locking has become a central part of that search. Consider the most common stars in our galaxy, the red dwarfs. They are small, cool, and incredibly long-lived. They make up more than 3/4 of the galaxy's stellar population. If life is common, it may well be found orbiting such a star. But because these stars are so dim, a planet must orbit incredibly close. To be in the habitable zone, the region where liquid water could exist, far closer than Mercury orbits our own sun. And at such a close, intimate distance, tidal forces are immense. For these worlds, tidal locking is not a possibility. It is an inevitability. What would such a world be like? Imagine standing on its surface. The red sun would not rise or set. It would hang fixed and unmoving in the sky. One hemisphere of the planet would be trapped in perpetual scorching daylight, a vast desiccated desert where oceans have boiled away. The other hemisphere would be locked in an endless frozen night, a dark side of immense glaciers and nitrogen ice. It seems like a planetary catastrophe, a world divided by impossible extremes, a paradise and an inferno welded together. For a long time we thought such worlds would be utterly hostile to life. But nature's ingenuity, and our own, often finds a way. Scientists now imagine a sliver of hope on these tidally locked worlds, a habitable region known as the Terminator Zone, the permanent twilight ring that separates the day side from the night side. Here the sun would hang forever on the horizon, casting long, dramatic shadows across the alien landscape. Temperatures could be moderate enough for liquid water to flow. Great rivers might run from the melting edge of the nightside glaciers to the evaporating basin of the sun-scorched dayside. Fierce winds driven by the extreme temperature differences would perpetually circle the planet, distributing heat. Perhaps in this eternal twilight under a crimson sun, life could find a foothold. Photosynthesis might adapt to the constant low-angle light, creating strange, sprawling forests that lean towards the stationary star. The search for life has become the search for these twilight realms, a search guided by our understanding of our own moon's captured spin. But there is another, even more profound possibility. A different kind of energy source for life, one that does not rely on the light of a star at all. We have seen hints of it in our own solar system, on Jupiter's moon Europa or Saturn's moon Enceladus. These are small icy worlds far from the sun's warmth. Yet, beneath their frozen shells, we are almost certain there are vast global oceans. Oceans of liquid water kept warm not by sunlight, but by the constant rhythmic squeezing of their parent planet's gravity. This is tidal heating, as these moons travel on their elliptical orbits. They are stretched and compressed by Jupiter or Saturn's immense gravitational field. This constant flexing generates enormous friction in their cores, heating them from the inside out, providing the energy to maintain a subsurface ocean and potentially powering hydrothermal vents on the sea floor, vents that could be cradles for life, independent of the sun. Now, project this idea out to the stars. Imagine a giant gas planet orbiting a distant sun, and around that giant, a small, rocky, tidally locked moon. This exomoon would be flexed and heated by its parent planet. Its interior could be geologically active, warm and wet. Even if it exists in the deepest, coldest reaches of its solar system, life could be thriving in its dark, tidally heated ocean, nourished not by light but by the rhythm of gravity itself. A form of life that would have no concept of a sun, a day, or a night. Its entire existence would be governed by the metronome of tidal forces. This is one of the most exciting frontiers in astrobiology. The notion that gravity itself can create habitable zones, and it is a concept born directly from our quest to understand the strange, silent motion of our own moon. So now when you look up at that familiar pockmarked face, see it for what it truly is. It is not a static, unchanging relic. It is a dynamic partner forever intertwined with the story of our world. Its constant face is a monument to the power of gravity, a testament to a 4-billion-year history of pushes and pulls. It is the reason our days are as long as they are, the anchor that stabilizes our planet's tilt, giving us predictable seasons. It has been a silent conspirator in the evolution of life on Earth, and now it serves as our Rosetta Stone, allowing us to decipher the conditions on worlds light years away. It is a laboratory for planetary science, a classroom for gravitational mechanics, and a signpost pointing the way toward the search for life elsewhere. Our journey started with a simple observation, a puzzle that has intrigued humanity since the dawn of consciousness, and it has led us from our own oceans to the hearts of dying stars, and to the twilight shores of alien worlds. It is the perfect embodiment of the scientific endeavor, a process that takes the familiar and renders it profound, that transforms a simple question into a universal revelation. The sleepy scientist stories are not just tales of the past. They are an ongoing narrative with new chapters being written every day by new telescopes, new probes, and new brilliant minds who dare to look at the ordinary and ask extraordinary questions. The universe does not give up its secrets easily. It whispers them in the language of physics, in the subtle motions of the heavens, and it rewards the patient, the curious, and the persistent. The next time you find yourself under a moonlit sky, take a moment. Feel the immense silent conversation happening above your head, a dialogue of gravity and time, of matter and motion. You are not just looking at a rock in space, you are staring into a deep truth about the cosmos, that everything is connected, everything is in motion, and that the most beautiful secrets are often the ones that have been hiding in plain sight all along.